We're finally here. Welcome to the SRHackoff 2022. It's actually the first in-person event that SRHacks is running, so pretty exciting. It's been a long 2 years. So I want to give a very warm welcome from our Science Rendezvous team. We have a bunch of staff looking around here. So before we actually get started with presentations, I just want to sort of talk about what we do at Science Rendezvous for those who may not know as much. Basically, we have an annual festival called the SR Festival. We have science fairs, we have very fun and interesting demonstrations, science experiments and demonstrations for people of all ages, especially youth. We also have our science art gallery. We have a lot of community engagement as well, outreach events, initiatives like I'm a Scientist, and SRHacks, which is a hackathon. So we decided at Science Rendezvous that we would like to give younger students the opportunity to participate in a competition like a hackathon. Typically, hackathons are software projects that groups of people from different disciplines intensively work on. So we wanted to bring that to a smaller audience. So SRHacks was founded in 2021 for that exact purpose. This year, it's a 2-week-long competition with teams of 1 to 4 people. The theme for this year's SRHacks was fostering sustainable communities, specifically promoting environmental sustainability and tackling issues related to disposable waste. I would like to say that this idea was heavily inspired by the UN Sustainable Development Goals. That's where my team and I got our main inspiration. We thought it would be a really good idea for younger students to tackle worldwide issues that the UN deal with. So what did our students actually submit for this competition? Well, firstly, they submitted a short video showing their project or invention, how it works. It was a product to essentially combat issues with disposable waste. They also submitted a written description of the product, which explains how it works, what issues they're tackling, and how the product actually tackles those issues. They had the option to make a marketing poster to showcase their inventions to a public audience. And if you see along the walls in the room, we actually pasted some of the posters that were made by other fellow competitors.
These past 28 days, during our 7 online events, we have witnessed over 370 brilliant young minds tackle one of the world's biggest issues, disposable waste. Over 283 students registered to compete in our hackathon, and we received over 55 project submissions. With that being said, we would like to give a big round of applause to all of our ingenious competitors who have made it to the final round of SRHacks. Your projects have greatly impressed our judges, and we are so proud of all the hard work you have put in. Today, we have $2,210 worth of prizes for you to take home. Finally, we would like to thank our 55 judges, 15 mentors, and 14 organizers for dedicating their time and efforts to making this whole event possible.
Right, so of that $2,210, the SRHack prizes include the cash prizes listed, $150 for first place, $100 for second place, and so on, as well as finalists receiving their own microbit. If you don't know what that is, it's essentially a little device that you can hook up to your computer. If you have the app Microsoft MakeCode, you will be able to essentially use it to code and control the LED lights on that little device. It's a pretty neat object. I have one myself. It's pretty fun to use. Now, I am going to go over the plan for the day, just as a reminder. It isn't the itinerary, but just so we're all on the same page. So student presentations will begin very shortly. We'll have 2 student presentations followed by our first break. Then after our break, we will have 3 student presentations, followed by another break, and then the booth mingle, where we'll give audience members the opportunity to walk up to the products of all our finalists up close and ask them questions that they may have. It's just a fun little way for audience members and the public to interact with their finalists and their products. One other thing to note is that finalists will have approximately 7 to 10 minutes to give their presentations, 10 minutes the maximum. Then following their presentations, we'll have a 5-minute Q&A session approximately given by our esteemed guest judges. The presentation and the Q&A session will be the main things that the judges will be marking and critiquing when they decide the final ranking of all of our finalists.
Thank you. And just as a reminder, as you're enjoying the pizza and refreshments in the back, the garbage is to your right-hand side, just beyond the double doors. So now we will introduce our judges. Our first judge is Dwayne, who is the founder of Science Rendezvous and has published over 300 papers, notably contributions into the development of ultra-bright electron sources to light up atomic motions. Today, Dr. Miller will be joining us from Zoom. The second judge is Mr. Chukwunonso Nwabufo, who is the founder of OneDrug and a multiple award-winning pharmaceutical scientist with over 5 years experience in drug development across academia and the pharmaceutical industry. Our third judge is Dr. Bojmehrani, who has a PhD in experimental medicine and is a second-year translational research program master degree student. Dr. Bojmehrani will also be joining us from Zoom. And our last but definitely not least judge is Mr. Bryan Ho, who is a commercially trained pilot, as well as aerospace engineering professional currently working at MDA on the new SAR satellite program. Mr. Ho will also be joining us from Zoom.
And on that note, I'd like to give a huge shout out to our SRHackoff coaches who helped our finalists prepare their presentation and coach them through the finish line. That's myself, Jenny, who is beside me, and Mimi. Not sure where she is, but she's a coach here for Science Rendezvous. So big shout out to those people. Yes. So we have our 5 finalists here shown. It's in the itinerary. We'll be getting presentations for products named Smartben, No More Hungry Plant Array, Community Clean, Kodra Spacecraft, and Elevator Energy Generation. So from there, it's time to present. We have our first presenters who created the EEG, Elevator Energy Generation. Edlin Tu and Jessica Pu, please come forward.
Hi, my name is Jessica.
And my name is Edwin.
Our project is EEG, pronounced EGG, the Elevator Energy Generator.
Using egg, we can crack the code to sustainable energy. There are many problems with current methods to generate energy that our egg does not have. For example, not all of them are renewable, like fossil fuels, and they're all expensive. For sources such as windmills and solar farms, they also depend on sources such as the amount of wind and sun to determine the amount of energy generated. Additionally, solar farms, wind farms, and nuclear power plants take up a lot of space, and land is getting very expensive.
Though many don't realize it, but there are many problems with current elevators. The invention of elevators in 1857 led to mass production of it ever since, and now there are over 1.8 million elevators worldwide. Surprisingly, elevators require more energy going down than up. So this might not seem like a big problem, but when this wasted energy is reduced in all of the 1.8 million elevators, we could potentially reduce the wasted energy worldwide.
In order to identify a problem, we looked at the various sustainable development goals, and our egg meets all 4 of these sustainable development goals.
This includes affordable and clean energy, industry innovation and infrastructure, sustainable cities and communities, and climate action. Here's an overview of our solution. Egg is a method to generate energy using any elevator.
Our solution is better than existing elevators because it doesn't use any energy while going downwards, and it also generates energy while slowing down.
The materials we use to make a prototype came entirely from our home. They're recyclable materials and old items that were going to be thrown out. We used cardboard and hot glue to make the building.
We also used a motor from a handheld fan as an energy generator, and an LED light from a broken fire alarm to display the energy generation. Here's a demonstration of our prototype. So, the component that you see over there is the component that we will be adding to the elevators. Instead of having to install a new elevator every time, we just have to install our component, which is made of the generator/motor, the LED, and the pulley. When the elevator moves upwards,
Just continue, sorry.
when the elevator moves upwards, the motor will be turning it to power it, and it will require energy. However, on the way down, it will not require any electricity, as it will be using gravity and the weight of the elevator to move it down. As you can see, when the elevator moves down, it also spins a pulley, and the pulley is what powers the LED, and it generates electricity. Currently, you have to spin it very quickly and very fast in order for it to generate enough electricity to power the LED.
Continue.
However, in the future, this will not be the case, and the amount of electricity generated will be determined by the amount of strength that you need to actually turn the pulley. This way, it will also slow down the elevator when it is moving down, so it does not just stop. Our component works similar to how most renewable energy sources generate energy. In a wind turbine, wind is the force that will help spin the rotor in order to generate power. However, in our prototype, it is gravity that will spin the generator to create energy.
Continue.
Traction elevators are the most common type of elevator, and the way they work is they use a pulley system, a counterweight, and a motor. It requires energy to turn the motor to move the elevator up, and it requires even more energy to turn the motor to lower the elevator. Our egg uses a similar pulley system. However, on the way down, it moves using gravity, so it doesn't require any energy. And the generator that slows it down, so it is not just dropping, also generates a lot of energy, which is demonstrated by the LED lighting up.
Here's how our motor generates energy. In the first video, you can see that energy is being drawn from the battery to power the fan blade. However, in the second video, the energy is being generated to light up the LED. This generator converts our mechanical energy into electrical energy. The way our DC motor works is that there will be an electric coil in the middle surrounded by magnets around it. When the magnets move, which is when the rotor is spun, the distance between each magnet and the coil will change, which causes an electrical current, which will be used to power the LED. One of the challenges we had to overcome when building the process was the challenge to connect the pieces. It was very hard to connect the pulley to the motor. First, we tried using a toothpick to connect it. However, the toothpick kept on snapping, and there was not enough friction between it. Then we tried using hot glue to stick it together. This was way more effective, and we managed to spin the rotor when the pulley spun.
Another major challenge that we had was the limitation of the amount of materials we had in our home. Instead of using an AC generator, we had to substitute it for a DC motor that also worked as a generator. In the future, when we have more materials, we will explain how our egg will have more additions to make it work better.
One last challenge we had to overcome was the wire constantly snapping.
Originally, at first the LED wouldn't light up, and we didn't know why that was happening. When we figured out that the wire wasn't connected, we were able to fix it and overcome these challenges.
One next step for the future of egg is to apply regenerative braking to generate additional energy. Currently, regenerative braking is a method to generate energy when a moving object slows down or stops, typically electric cars.
It works by converting the kinetic energy of the object that is moving really quickly into electrical energy. And when it converts it using a generator, the object will stop moving.
Since elevators slow down and stop very often, there are many opportunities for regenerative braking to be applied.
Some more next steps that we will add include adding a rack and a pinion to the side of the elevator. And we can also connect a generator to the gear and the rack and pinion to generate energy through there.
This time, the generator will be inside the elevator instead of usually being at the top.
We can also change the speed that the elevator goes at by switching between gears or switching between different generators. This way we can control when to slow down or when to stop the elevator.
This will provide more accurate motion, and it will also be safer for the user.
Some other additions that we will use when applying our egg into the real world is, instead of having the energy generated to power an LED, we will attach a battery to store the energy. And then when the elevator moves up, we can use the energy powered to power it.
Another addition is to use gears to increase rotations and energy generation. For example, the larger gear, gear A, when it spins once, the smaller gear, gear B, will spin many more times than the gear A will.
The larger gear will be connected to the pulley, and then the smaller gear to the generator. That way, when the pulley does one rotation, the generator will be spinning many more times. This will also result in more resistance generated, and so the elevator will not go down as quickly.
Another item we can apply egg to are escalators.
Escalators work similarly to elevators in the sense that they also use gravity when moving, downwards. We can use our same egg component. However, apply it to the top and the bottom of the escalators.
Conclusion.
We hope that our egg will be the next step towards more sustainable cities and communities. Our egg is also cheap, and we hope it will be accessible to all buildings around the world. Because gravity is free, why don't we use it to help make energy?
Feel free to visit our website at this link.
The end. Thank you for listening to our presentation. If you would like more information, you can look at our booth during the booth Mingle to see the prototype up close.
Very nice. Now, are we able to ask questions now, or?
Yeah, so feel free to ask any questions you have, the judges, for this presentation.
Okay, so the other thing too is the video, we weren't able, at least I wasn't able to see the video, so I was just following along on what was presented on the video camera.
Just do the normal screen share.
So maybe I could ask, what fraction of energy do you expect to be able to recover with this idea?
I'm sorry, can you repeat that question?
It's basically a cost-benefit analysis. How much energy do you think you could recover using the elevator's gravitational potential? But what would it be? How much power for, let's say, one skyrise, one elevator? What would a typical power generation be?
It really depends, because sometimes when we add gears, we could increase it a lot. And sometimes if we add regenerative braking, then we will also increase it a lot. So there are many ways you can increase it when we generate energy.
Also,
Right.
depending on the different types of elevators and the amount of weight that it has and the distance, these are all factors that will affect it. But overall, it will be a significant decrease in the amount of energy an elevator uses right now, because it will only be using energy going one direction, and it will also generate.
Right. I guess what I'm asking is how much energy would be saved or generate that way? Like how many watt hours would a typical elevator produce per year?
We can't actually get the exact number of watts, because our generator that we have right now in our prototype is not like the actual one. And right now it's not a lot, because it is just enough to power an LED. However, an actual elevator will be a lot more, but we can't determine the exact number.
Yeah, I was just thinking, like I think of normal, I go up, let's say 20 floors, the elevator goes down, so much power is generated, but it's for a short period of time. I think the idea is great because you save energy at every possible way. I'm just wondering how much power you could generate. That's kind of interesting.
Yeah, we're not exactly sure. There are many factors that affect it.
Okay, I think you could calculate it if you just measure the maximum energy you could produce and what a typical ridership would be per elevator. You could get an idea of how much energy you could save. That would help your case in terms of justifying the cost to make such a generator.
Okay.
Anyway, I like it. It's great. Thank you.
Yes, so if we have any more questions from judges, please ask our.
Yes, so thank you very much. It was very interesting, very interesting topic, great presentation. Unfortunately, we didn't see all the presentation slides, but we listened to it and it was really good. So I have two questions for you. My first question is how you're going to stop the elevator, for example, at a second or third floor. If you're using the gravity, how you're going to stop it?
So that's where we apply our regenerative braking system. And basically, it is the same thing that is used to stop an electric car while generating energy. So the regenerative braking is a generator, and then we can switch between the generators, and then the regenerative braking system will be able to brake the elevator between floors whenever we would like.
Awesome. Thank you very much. My second question is, have you ever asked any other normal people if they know that the elevator is working with gravity, they're going to use it or they're going to afraid to use it? How you are going to protect their security?
Can you repeat that question, please? I couldn't catch it.
I said that if you ask the people if they're ready to use an elevator that's working with gravity.
I believe it will be ready because it is better than an actual. Gravity is consistent. It will not suddenly drop or anything. Currently with the motor, like the speed could change or it could stop working. And if the elevator will drop without anything to stop it, then that is more dangerous. I believe that if we attach our system, then it will actually slow it down and there would not be a significant difference between elevators right now and our elevators egg.
Okay, great. Thank you. Good luck.
Okay, so in the interest of time, I think we're going to have to wrap up. Thank you very much, Evelyn and Jessica, for your wonderful presentation. So we are experiencing a bit of technical difficulties. So our next presenter is Jerome Stevens with his No More Hunger plant array. But we're going to give him a few minutes to set up and give a few minutes for us to figure out the tech issues that we're currently having. So please be patient. Thank you. So yes, technical issues. Okay. I was unmuted. Technical issues haven't resolved. Jerome Stevens is just quickly setting up his product, and then we'll get started once he's set up.
Hi. Is it working? Hi. Hi. Is it working?
Yes, it worked very well. Don't worry.
It's working?
Yeah, we can hear you.
Okay. Hi, I'm Jerome Stevens, and for my presentation, for my entry, this is not working. I've made a special planter called the No More Hunger plant array. We all know hunger is a big problem. It's one problem that I'm gonna move this thing. How do I move this? Oh, gosh. Yep. We all know hunger is a big problem. It's one problem that we seem to just not be able to fix. Well, no more. I've built a new type of super efficient garden made of pipes and bottles that will end world hunger easily and quickly. I call it the No More Hunger plant array.
We can't hear, sorry. I mean, I guess you know that.
So, should I start speaking now? Oh.
Copy down.
Yep, that works. Relevance. People who are hungry normally do not have a place to grow food. Because they normally do not have a house or enough money to buy what they need to grow. Solving this problem by giving people a place to grow food made of completely reused material which can be found easily. This machine can be used no matter the climate in the place you live. It fits any type of plant, which is quite important because not all climates can support the same plants. Therefore, it can be globally used. So now I've put a plant chart here to show what kind of plants can be grown in different places, such as coconuts in South Asia. How do I move this? Coconuts in South Asia, Southeast Asia, the Pacific region, and that's all. Idea. My idea was to create a small array of planters to grow faster growing plants. I added automatic watering through these bottles. It's portable. It uses completely reused materials, and it's weed proof. Materials I used: a PVC pipe, some old plastic bottles with plastic caps, some tubing or hosing, two small circles of plastic, two stands or stakes, some soil or dirt, some seeds, water, and the tools I used were a drill, a hole cutter, a glue gun, and a saw. Building. To build this machine, I sawed a PVC pipe in half, one half for the plant rail here, and another for the watering rail. And in one half of the PVC pipe, I drilled 4 2-inch radius for the plant rail. I cleaned the bottles and poked holes with 2 millimeter radius in the bottle caps. I inserted some tubing here into the hole. I poked some 4 millimeter radius in the bottom of the bottles here. And then I attached the PVC to a stand lower down than the watering rail, which I trapped the plate rail with a piece of plastic. Well, actually, first I glued onto the watering rail, which is one PVC without holes, the tall one, and capped the plant rail. I then filled the plant rail with soil and put the plants in. So these have been growing here for 2 weeks. 2 weeks ago, they were about an inch tall, maybe 2 inches. I filled these bottles with water twice. And now they're huge. Then I ran the tubing from each bottle to its corresponding whole soil. I put water in the bottles and watched lunch grow. Challenges that I face. Learning to use the drill. I learned that I had to keep the drill steady. I shouldn't push it into the pipe and to use the trigger very, very gently. Then the hot glue wouldn't hold up the bottles, so I had a lot of trouble with that. I ended up switching to hockey tape. The bottles couldn't do a slow release of water, so I put stoppers made of hot glue and screws into the holes in the bottoms of the bottles here, and that would limit the volume of water and air in the bottle, causing a slow release. Demonstration. So the way this works is I've got my plants here, and then to water them, or to activate the slow release, I take one of the caps out, fill the bottle with water, and then just put the cap in. It worked really well for the most part. I did have to fill it a couple times. The original designer was supposed to only fill it once. The improvements I could make. I could add more planters and bottles because the design allows for more planters and bottles. And more planters means more output and greater variety. I could add wheels for more mobility due to the fact that in some climates, it's really cold in the nighttime, hot during the daytime, so you'd have to move it to different places for it to survive, for the plants to survive. I could make it large enough for bigger plants such as prickly pear cacti or even trees. And then I could add connection to a water system, such as stored rainwater in a collection system. Other applications. It could be used as part of a community garden. It could also be used for people like me who are so addicted to gardening, they might want to garden during wintertime. It could also be used simultaneously as a trellis for vining plants. Thanks for watching my presentation.
Thank you, Jerome. That was amazing. All right, now we have 5 minutes of Q&A time for any of our online judges and also Mr. Nwabufo. Yes, Mr. Nwabufo, question? Your mic is not working. Would you like to come out to the front?
Hey, Jerome, maybe while we're waiting, do you know?
By the way,
I'm
so
sorry.
the question I have is, for plants that are bigger than the current size that you have now, how do you think you would address that?
So to make it able to fit bigger plants, I could simply make the planters bigger with a larger water supply. And well, just adjust the size of the holes based on the type of plant, size of the plant.
Okay, what from a length perspective though, can you reduce this a little bit to accommodate them if it's a bigger plant and it's not able to withstand the current force that you have here?
I could make it, I don't really understand your question.
Okay, so if you have plants that the lengths are way bigger than the length you have now, do you think that if they grow longer, that they will be able to fit in here?
Yes, actually, because so you're talking about just like vines, right?
Mm-hmm.
So they could fit, they just be like mangled together.
Have you also thought about pest challenges? How would you deal with pest issues? Yeah.
So you mean that by bugs, right?
Yeah.
Okay. So I don't exactly have a way to deal with bugs, except for the fact that there are only these ways to exit. So I could just like spray some kind of bug repellent around these holes, which would repel the bugs, meaning they couldn't get at the plants.
Thank you.
Hi, Jerome, I've got a question.
Thank you so much. We have time for one more question from the judges. Do we have any questions?
Yeah, I've got a question, Jerome. Can you hear me? Can you hear me?
Yes, of course. Go ahead, Mr. Ho.
Yes, thanks. So Jerome, thanks for looking into this. Definitely world hunger is definitely an issue in today's world. My question for you is, you mentioned a lot about climate control, right? So how you can control climate, how different crops across the world grow in different climates. I'm looking at your product. I'm wondering, how are you controlling climate? Like heat, for example. If you think bananas, oranges, cactus grow in hotter climates, whereas maybe apples grow in colder climates. How are you controlling that variable in your product?
So for heat, so let's say you live in a really hot country, like near the equator. You could just, well, this is very light. So you could essentially carry it to a place with shade or a place where there is something to keep it cool.
So you would have to keep this outdoors. It's not an indoor system.
I didn't hear you there. What did you just say?
So yes, so my follow-up question was that you would have to keep your no more hunger plant array outside, not inside your house or by a window. It would have to be in your backyard or garden.
It could be a backyard garden and it could be indoor too. I think that's what you asked, right?
Yeah. Okay, thanks for that, Jerome. Appreciate it.
Thank you so much. And thank you so much, Jerome. We'll now be moving on to our next presentation.
Oh,
So since we had a delay in the initial start of the presentations, we're actually going to skip our first break. Everyone has already gotten refreshments and food. So we're now going to move on to our next presentation. We have Ryan Rad presenting his product, Community Clean.
Sure. Yeah, like that. How do I, let me turn on the person. Hello, my name is Ryan, but before I get on with my presentation, I have a question for the audience. Raise your hand if you ever wish to contribute to your local community, but you don't know how or when to start. Well, I think my app, Community Clean, might be the solution for you. Litter is a problem, a big problem. If you look around you, statistically, 3 out of 4 people you see have contributed to this problem, according to a recent US study. Furthermore, according to the KAB organization, there are approximately 2,000 pieces of litter per mile. This adds up to millions of tons across America alone. This waste costs American taxpayers a collective $11 billion per year, far greater than the cost of traditional garbage collection. Personally, I can't even remember the last time I went for a walk and didn't see garbage somewhere it shouldn't have been. It is clear that there is a lack of action when it comes to keeping our communities safe and clean. In order to build a solution, we first must identify the problem. It is clear that communities need to be cleaned and are being neglected. Government funding and initiatives have not been sufficient in tackling the issue, so rationally, I decided to look towards the private sector. We know that based off economic principles, individuals react positively to incentive. Therefore, I decided to design a system through which citizens are incentivized to improve the cleanliness of their local communities. Community Clean is a gig economy-based app that pays citizens for participating in cleanups of local parks, playgrounds, and facilities. It allows anyone to host events with a set budget that is then distributed to event participants at a rate determined by the degree to which they have participated. It's as simple as downloading the app, finding an event you wish to join, going there, cleaning up, and getting paid. This works similar to apps like Uber and DoorDash with how they reward their drivers. This app was conceptualized using Figma as a proof of concept. Now on to the demonstration. Here is the homepage of Community Clean. There is a map and a search bar, as well as 4 tabs. Here, let's say we were to join this event, it would take us to the details page, in which it has the name of the event, the host, the starting time, the ending time, the start time, the end time, the date, the amount of volunteers registered, the amount of positions left there are to register, as well as the reward being offered and any additional information if there is any. Here, if you were to further press join, it would grant you a little thank you message. Thank you for registering for the community cleanup. With your help, we can keep our community clean 1 bag at a time. Then after this, you'd simply go to the event when it is time. This app would track your location and your movements in the area of the event, similar to how the health app on your phone will track your steps. And it will use that data to distribute the pay across everyone depending on how much they've been moving around. It will also require you to send an image of the garbage you've collected in a bag after you've finished the event for manual verification. This is the withdrawal page, my earnings page, in which users can view all their earnings from what sources and from what certain timeframes, as well as the amount of cleanups they've completed. And if they wish to withdraw their money, they can. You're given the option to search between your last 7-day earnings, your last 30-day earnings, your all-time earnings. It'll also show the cleanups within that time frame. If you were to press withdraw, it would simply transfer the money to whatever account you have linked with the app, whether it be PayPal or a bank account or a credit card. Now I'll just leave this on the screen for a bit. This is a QR code that leads to an interactive demo of the Community Clean app. So feel free, I'll just leave it on for a bit. That's for anyone who wishes to, feel free to scan it. With that, now on to the summary and my future plans for the project. I personally believe that it could be further improved upon by installing proper physical and digital security for the events, a method to confirm the participants have cleaned the area, as well as the way to converse with other participants through the app. This could also be used in other contexts by schools, hospitals, and businesses to set up fundraising events. It could even be monetizable through charging small fees to businesses that utilize the service, as well as a tiny percentage of the payouts of the participants. Thank you for listening. Do you have any questions?
I guess I'll just jump in. So Ryan, very nice presentation. I like the idea of trying to get rid of litter and that, and your identification of incentive. Who's going to pay? How do you incentivize the sponsors in the first place?
Yeah, so the host would be the one to set up a certain budget, and depending on the data tracked between all the users and their steps in the area, it would then calculate how evenly to distribute the money across all the participants.
Okay, because I'm just thinking if the government isn't paying for litter clean, like they have park services and things, just off the top, right? Something like a TD Bank or something doing an event like clean up Thompson Park, but you would need to have some other marketing or something to get the sponsorship for such.
Could you repeat? I don't think I heard that very clearly through the speaker.
Just the government pays for park cleanup and things like that, which is insufficient. So you'd really be looking for additional sponsors like a TD Bank. Let's say, just an example, clean up Thompson Park. You would need to have another part to the business that would get these online sponsors, right?
Yeah.
So how feasible do you think that is? Like, why aren't people doing that now?
Huh? Oh, hi. So. So after the event is completed, volunteers will be required to take their phone and actually take a picture of the garbage they've collected in the bags in order to first to be like manually verify that they actually cleaned the area. And the payment will not be like transferred to the earnings page until that's been verified. Oh, can you say that again? I didn't. So you said the host of the event is one of these. So how does the conversation that's announced to create people have volunteered to meet? Yeah. How does that compare? It compares by there's obviously not only yes, it's a lot more cheaper because you don't have to pay for the garbage truck and everything. People simply come, it's like Uber drivers, they don't have to pay for all the expenses. They just come with their own equipment, they do the job, and then they get paid. The money is distributed depending on the amount of work that each volunteer has done. Yeah, it would be paid via the app. Like I plan to add a system in which you can link payment details like your bank account or like a PayPal account to the app, and it would transfer the money from the earnings page to there. Yeah, I have not like thought into that yet, but I plan to like elaborate more on that when I get the chance.
Thank you.
Thank you.
Hi,
Any of our other judges have any questions? We can take one more question.
yeah, right. I'll ask a question. First of all, a great presentation, and great use of Figma. I know a lot of tech companies, like Facebook use Figma for their mockups.
Oh, sorry, Brian, can you repeat your question? We couldn't hear you the first time.
Yep, can you hear me now?
Yep.
Okay, well, hi Ryan, so this is Brian here. So first of all, great presentation and great mockups using Figma. A lot of big tech companies like Facebook, use Figma for their mockups. So I'm glad you're using, one of the industry tools. My question for you is, historically in these sponsored events that contribute towards, let's say garbage cleanup or some sort of cleanup, what ends up happening is that your citizens or whoever your target market is, they often end up littering more, trying to get the rewards, try to make more money. So what happens, historically in other countries and even in Canada is that they would purposely gather garbage and litter more, create more garbage to make more money back. I'm wondering, do you have any comments on how your app would address that?
So you mean like, how could they just like litter just to get the cleanup? Or
yeah, so for example, hoarding garbage in their backyard, and come time for community cleanup, they'll just bring up 5 garbage bags and claim $50 worth of work, as opposed to actually cleaning up parks. Have you ever thought about that?
I think you were muted for part of it. Could you repeat it?
Yeah, for example, like if certain people might hoard garbage, for a given week, knowing there's a cleanup coming up, and then they might just take pictures of the garbage bags and then claim $50 worth of work instead of actually cleaning up the park. Have you ever thought about how you would address that?
Well, first off, I plan to add a way to actually track your location as you take the photo. So it's confirmed that you're in the area of the event as you take the photo, as well as it will be manually verified. So if it's if people notice, moderation will notice it's the same picture of the same exact garbage bag.
But also your app tracks movement, so you could see the movement within the zone that they're active.
It would work.
No?
It would work similar to the fitness app on your phone, the way it tracks your steps. However, it would only track your steps, and it would only contribute to the amount to the data as long as you're in the area, like the radius in which the event is.
Can you just create a GPS for that one so we can follow all the steps that they're doing or not?
Wait, could you repeat that?
Can you provide a GPS? For example, they can follow where they're collecting, how much time they're working, and the roadmap, something like that.
Yeah, there's going to be like a map that will show the area in which the event is taking place, and it will notify you if you leave that area to make sure it'll notify you are you sure you wish to leave the event, and it'll say if not, then I'll re-enter the area.
I've got one other quick question on the tracking part. What people don't like to be tracked, generally speaking. So do you think this should be widely accepted? I mean, that people would want to have an app that's tracking their movements? I'm just curious as to if you looked into, for example, the COVID-19 tracking app was somewhat successful, but that was a major health crisis and people agreed to do it.
It would be consensual to track the app, similar to how most map apps will ask, are you okay with us using your location?
Yeah, okay.
But every time you would have to perform something that requires your location, it would prompt you to do it.
Yeah, I mean, I guess an Uber driver, same the point you made, yeah. So if you want to be paid, you got to be tracked for some period of time.
Yeah.
Yeah, thanks.
Okay, and with that, we'll be ending the Q&A session for Ryan. Brad, thank you so much for your presentation. So now our next presenter is Bryan Ho with his project Smartpin. He's just going to take a few minutes to get set up, and then we'll let you know when he's ready to present.
Sharing now.
Welcome to Smartben. I will tell you where the piece of garbage. Ask me a question. Using Smartben. Goodbye.
Give me 1 second. Yeah. Oh, shoot. Oh.
Hello, everyone. My name is Brian. I'm in grade 8, and today I'm presenting to you the Alexa Smartpin, helping you throw away trash responsibly and quickly. Here's the problem that my Smartpin will face. It's that many Canadians often throw their trash into the wrong bins, mostly out of laziness, but sometimes ignorance. It's shameful, it's awful. In some instances, almost 1 in 3 pounds of what goes into a blue box shouldn't be there, says Mark Badger, an executive vice president of Canada Fibers, which sorts 60% of the trash collected at your curb. Why is this important? Well, it's because misplacement of trash can cost recycling companies millions of dollars a year to sort through your misplaced garbage. It can also contaminate recyclable items, and it will increase the size of landfills, because even bits of trash can contaminate paper, which ends up in landfills as paper waste. And here's the solution, the Alexa Smartbin, which is an Alexa app that when asked, tells you where your trash belongs. Why should you use Smartbin? It has many advantages. First, being that it's stationary. If you use a device, you may often move around and lose it. That's why Alexa is stationary and is easy to find. It's also for all ages, because kids and other people who may not have their device will be able to use the Alexa Smartbin. It's also voice activated, so you won't have to find your device and enter your password. It also gets straight to the point. You won't have to Google it, you won't have to search it up, you won't have to wait for it to load, and you won't have to scroll until you find your answer. All you have to do is ask Alexa to open Smartbin, input your item, and you'll get your response. Why I made Smartbin an Alexa app? I chose Alexa because Alexa is one of the most popular virtual assistants in the world, with 68.2% of Americans having one in their households in 2022. It's also because the Alexa developer console has many unique features, which makes it easy to use. And it also uses Python, which I have 2 years of experience in, so I'm pretty familiar with it. Now, onto the demonstration portion. For my partner Alexa, the trash bin, the recycling bin, and the blue bin in this pile of trash that I'll sort into these three. First, cardboard. Alexa, open Smartpin.
Welcome to Smartbin. I will tell you where to put your garbage. Ask me a question.
Tell me about cardboard.
Cardboard belongs in the blue box as it can be reused. Anything else?
Tell me about glass.
Glass belongs in the blue bin.
What about paper?
Paper goes into the green bin as it is made of wood and organic.
Does phone belong?
Electronics are to be dropped off at your local household hazardous waste depot.
Banana.
Fruit belong in a green bin as it is organic.
What about battery?
Batteries are to be dropped off at your local household hazardous waste depot.
Alexa, stop.
Thank you for using Smartbin. Goodbye.
That concludes the end of my demonstration. Now moving on to the insides. How Smartpin works. Part 1, its basic structure. On the right is a simplified flowchart of my code. Most code were already imported from the Alexa developer console, which is why you won't see functions like speaking and responding. So when it starts, it will import the spreadsheet with all the items and its descriptions and then it will say a greeting and then ask for an item. After receiving the item, it'll make a dictionary, matching the items with the descriptions so the descriptions can easily be called upon. And then we'll check if the item is in the dictionary. If it isn't, then I haven't added it to the spreadsheet. So we'll say, sorry, I don't know about that. And we'll ask for another item and repeat. But if it is, we'll tell the user where the trash belongs before asking if they have anything else. If they say no, then we can end the program from there. But if they say yes, we can ask for another item and redo all the steps. Second part, sentence structures, which is how Alexa can receive and understand information that the user inputs. She will only understand if you phrase your sentences that specific way. So for example, if you say, Alexa, please help me, where do I put this item? She won't understand you because the sentence is too complicated and long. Only sentences that I've added, like, what about item, will she understand. And now this is the spreadsheet where the program gets the information from. On the left are the items, and on the right are the responses. So if you say an item on the left, like water bottle, then Alexa will tell you the response on the right of that item, like plastic water bottles belong in the blue bin. Future improvements. Currently, Smartbin only has around 90 items. So items that aren't on the spreadsheet can confuse Alexa. In the future, I'll add more items so Alexa will be able to respond to different ones. I can also add a feature that allows people to recommend the items that I can add. I can also add another feature that allows Alexa to understand items with additional letters and words. For example, if you say blue water bottle, it won't understand, even though water bottle is on the spreadsheet. Next, Smartpin can easily be confused by sentence structures. In the future, I can add more sentence structures for the developer console, so she'll be able to understand a larger variety of sentences. Lastly, different cities have different recycling laws. So using the Alexa developer console, I can detect locations and can adjust the spreadsheet and item descriptions based off the locations. Now, the conclusion, now that my presentation is coming to an end. Smartbin, a simple Alexa skill that when asked, will tell you where your trash belongs. The Smartbin will increase sustainability and decrease waste consumption in communities across Canada. Smartbin, making it easy to keep our planet clean. Thank you for listening to my presentation. Questions?
So yes, very good presentation, excellent programming. And it was really, really interesting and it's going to be very helpful. I have a question for you. So this one can just be used at home and with Wi-Fi access, or it can be used anywhere?
Yes, they require Wi-Fi. So if your Wi-Fi is weak, then it may take a while to respond.
Okay, so it means that they cannot use it on a camp without any Wi-Fi connections.
Yeah, that's why it's best kept at home where you have
Okay.
Wi-Fi connection.
Great, thank you.
So great presentation, Brian. I just have a number of follow-up questions. You know what? I agree that this is a great problem. You know, we struggle with placing our waste correctly in the right box. But what I don't know is if this occurs more at home versus when we're outside. Did you look into that?
Sorry, can you repeat that question?
So with the misplacement of waste, do you think it occurs more at home versus when you are outside, for example, at school?
I think it's useful everywhere, but mostly in public places like outside, so more people can use it.
So if it's in public places, what are some of the challenges you think we may have with using your Smartbin? Because people use Alexa more at home versus in public spaces.
Well, outside, people may take the Alexa to steal it or something, and they may also, there may be a large lineup of people who want to use her, so it might be confusing or cause trouble.
Thank you.
So maybe just, can you hear me? So, right, how did you look into, I mean, how does the assumption, at least I assume the assumption is Alexa will help get over a problem that apparently people can't read signs. Like on a recycling bin, it has a picture of what should go in a particular bin. So is the argument you're making that this would help people? Because I do agree it's somewhat confusing often as to which bin to put things, but is that the rationale for the invention or development?
Sorry, I didn't hear the question really well.
Oh, you can't hear it? So what, can you hear me now? Hello?
Yeah, I think I can hear you.
So how does this approach improve the situation to incentivize recycling over just signs on recycling bins? What goes in green, what goes in blue bins?
Oh, so the Alexa spreadsheet is more compact, and you won't have to like search through the many posters of like where the trash belongs.
Right, but if I have a trash bin, it's got a picture of what goes in it. How does? I guess I do agree. It sometimes confuses people, but how would you convince somebody to buy this over simply putting a sticker on a bin with a picture of what goes in the bin? Don't worry, it's okay.
So I think some of the bins, they don't have picture in it, and we are so lazy to go and find which one is good to which one, so we just ask the question.
I think the picture, see, the problem is I think the pictures don't help, right? So I don't think Alexa will help either. That's my point. But I think if you do the cost analysis, where recycling gets to be a real problem, as I understand, if you recycle plastics, but there's sugar on the plastic, it causes damage in the recycling process. So there may be a way to tweak this so that people recycle properly. There's a sorting within the recycling process. Anyway, this is all great. I loved it.
I think Alexa is better than stickers because many people already have an Alexa at home. In fact, 68.2% of American households have one. So they won't have to buy one to use it. All they have to do is download a skill, which is not currently available. And
Right. But I've argued to 100% of families have stickers, right? So I think the fraction of people who have Alexa doesn't argue that they'll fall. I mean, it's a bit of a false argument.
But there are some confusing items like receipts, because some receipts belong in the trash if the paper is different, and some belong in the recycling bin. So the Alexa gives you more information than stickers.
Okay, thanks.
Alexa actually distinguish the different paper types?
No, so if you say receipt, then she will say like thermal receipts belong in the trash and paper receipts belong in the blue bin. Oh.
All right, thank you so much, Ryan. Unfortunately, we are out of time right now. So let's give a warm round of applause to Bryan. And we're now going to welcome our last team. So our last presentation is by the team of Dian Soni, Ansh Shah, Aryan Marwaha, and Xavier Sidhu, presenting the Kodra Spacecraft. Ladies and gentlemen, a warm welcome for our final team. The mic is on.
Good afternoon and welcome to the unveiling of the Kodra spacecraft. The Kodra has been designed to allow for safer space exploration through the removal of space pollution in the form of debris. Our team consists of Dian Soni, Xavier Sidhu, Ann Shah, and Aryan Marwaha. Today we will be exploring the desperate need for the Kodra spacecraft. It was created as a solution to the expanding problem of space debris. We will be showcasing the concept and discussing potential improvements to the current design. About 100 kilometers up, there are thousands of satellites whizzing around at ludicrous speeds. These satellites help our world function. Without these marvels of engineering, our world would not be the same. But there is another side to the story: space debris. Space debris is any object in orbit that no longer has a function. The problem with space debris is that it's so widespread. According to the European Space Agency, there are over 131 million pieces of space debris in low Earth orbit. In addition to this fact, the reality is that every piece of space junk has a tremendous amount of energy, capable of causing extensive damage. In 1983, the space shuttle window was hit with a tiny speck of paint, smaller than your fingernail. This caused massive damage and required a full window replacement. If this problem continues, we could literally trap ourselves on Earth. It could become impossible to launch into orbit without being hit with the barrage of tiny space missiles. Make no mistake, space debris is a catastrophic problem that we have to solve now. So what do we do? Asking ourselves this very question, we invented a new way to capture and deorbit large pieces of space debris. Please turn your attention to a 3D model of the Kodra spacecraft. This should be audio. Yeah.
We're traveling near 7,600 meters per second. If you want to do, here's a catalog of the Kodra spacecraft that was designed and used recently. The intention of the design.
Here's a schematic of the Kodra. You can see various components such as the electromagnet, the avionics package, and the fuel and oxidizer tanks. Next, you'll see the illustrations of the physics behind the Kodra spacecraft. First, the Kodra is launched into orbit, as you can see in this video. Now the Kodra will turn on its Lidar system to detect pieces of space junk. Once the debris is detected, information will be transmitted to mission control. Next, the spacecraft is positioned in the direction of orbit using the RCS thrusters. You can see a video of the Crew Dragon spacecraft using these thrusters to dock with the International Space Station. After contact is made, the electromagnet activates and attaches both craft together. Next, the engine will fire, reducing the velocity of the space debris and the spacecraft. The trajectory of the space debris reduces until it reaches into the atmosphere. At that point, the atmospheric reentry causes the buildup of superheated gas known as plasma. This plasma causes the debris to disintegrate.
The first optimization made was the use of an electromagnet instead of a more conventional tether or hook. The electromagnet is a simple and elegant solution. The second optimization made is use of a hydrolux engine. As mentioned in the video, this creates the most energy efficient engine possible, allowing a compact but effective design. Finally, the use of an aluminum airframe ensures that the Kodra spacecraft remains lightweight.
So now we would like to demonstrate how our spacecraft functions. As previously mentioned, the Kodra spacecraft is launched into orbit. Eventually, when space debris is found, information is sent to mission control. Then, using the RCS thrusters, the craft repositions and latches onto the debris with an electromagnet. The engine then fires and deorbits the craft.
Here's the code for the Kodra spacecraft. It will first try to detect the space debris. Once the debris is found, the RCS thrusters are used to move the Kodra. The two craft attach using an electromagnet, and then the engine ignites. This places the two craft into a trajectory in the atmosphere. Going forward, there are a couple of ways the Kodra spacecraft could be further developed to reach optimal performance.
The first priority of this project would be to upgrade the spacecraft to capture smaller pieces of debris. Currently, the Kodra spacecraft is designed primarily to eliminate larger pieces of debris, such as the satellite, but the ultimate goal is to have it remove micro debris, such as metal shards.
Our second aim and pursuit to improve the spacecraft would be switching propulsion methods from chemical to ion drives. This change would bring a higher specific impulse, or ISP, as opposed to chemical propulsion. And this would really boost efficiency. Ion propulsion is also cheaper than the conventional method, which is why it would be beneficial to look into this and make the change. The new goal of the space industry is reusability. It would greatly enhance our design if we could reuse the spacecraft. The rudimentary design suggests storing multiple tanks of hydrogen and oxygen. After one set of tanks are expended, the new one is replaced. One tank is used to deorbit, and the next set is used to place the Kodra spacecraft back into orbit. This cycle continues until the Kodra runs out of fuel, after which it deorbits and bumps up in the atmosphere.
So these are the different sources we used in the making of this presentation. And finally, that concludes our presentation on the Kodra. The Kodra is the future of solving the ever-present issue of space debris, currently plaguing space missions. The innovative design and concept will ensure a safer environment for the future of space exploration. We thank you for this opportunity to share our vision, and we appreciate your time and interest.
Okay, thank you very much for that wonderful presentation. Do we have any questions, judges?
Yeah, I have. Congratulations. This is very, very innovative idea. So it's very different from other ideas and very nice presented. My first question is, which material are you going to use? Because you're going to send it to space, am I right? So then space has a specific environment. All the materials that we can use on the Earth is not going to be compatible on the space. So which kind of material are you going to use?
Right. So a lot of the spacecraft nowadays, they're made of some kind of metal, either aluminum, and some of them are made out of steel, some important parts, right? And we want to keep the weight of the spacecraft down. So we're using aluminum since it's lightweight. It can withstand the crazy environment that is space, but it's still going to fulfill our purpose pretty satisfactorily.
Do you have any idea how much it's going to cost? And another question is, when the machine is going to capture the debris, what is going to do with that one? Is there somewhere I can store it and then bring it to the Earth, or what will happen to them?
Right. So number one, when we, like, as I said in the next steps, we were pursuing reusability, and as the cost of sending a satellite to space is going down, the cost of our missions will also go down, right? And in regards to your second question about where does the debris actually go, a lot of the debris, so any debris that enters the Earth's atmosphere that does not have heat shielding or protection against heat, it'll instantly burn up because of the plasma that builds up.
Great, thank you very much.
Great. So I have a few quick questions. Aluminum melts at about 700 degrees centigrade. Did you guys look into aluminum? I mean, it's lightweight, it's true, but it's got a low melting point.
That is true, right?
Did you, is
right now
aluminum used
our
in
spacecraft is
spacecraft?
not reusable, and that's why it's really a one-time use thing, as in it captures a large object, deorbits, and it does melt up. But when in the next iteration with reusability and whatnot, then the intention is to have, as I said, expendable tanks. But we also want to try upgrading to some kind of material that has, number one, heat shielding and a higher heat tolerance. So tungsten would be too expensive, but some kind of alloy would be good. Plus, we want to try using a blade of some sort.
Yeah, I think titanium would probably be pretty good. But the other question I have is, I thought most of the space junk is not necessarily ferromagnetic, right? So your idea of using an electromagnetic hook, how does that work for things that are not ferromagnetic?
Right. So again, the thing about our design, it's super versatile, right? So if a scenario does come up where we have like a known target where we do want to take this out and it has no ferromagnetic material, it's really easy to swap out and say use a tether or something, because a lot of the satellites nowadays, they have inbuilt hooks and tethers where you could attach say like a normal tether like you see on a truck or something and try to tether it that way.
Right. Okay. What are the other agency, NASA, European Space Agency? What are they proposing for cleaning up space debris? I mean, you cited a couple reports, but I assume they've got some ideas on how to marshal that landscape.
So according to what I've read, a lot of the NASA, SpaceX, those guys are trying to focus on taking out the smaller piece of debris, right? So there are independent research projects trying to go for the larger satellites like we're going, but in terms of the smaller debris, say metal shards, micrometeoroids, there's a lot of ideas about saying using nets and other like mass capture methods. And for like large satellites like we're using, they have been talks about say lasers and tethers that we're doing. There was a spacecraft that we also came across. It was very similar to ours. I believe it was called the Elsa Spacecraft. And that was, it had a very similar working principle to what we're doing.
Okay, the one thing, I'm just thinking of a cost analysis. So I love your idea and congratulate you on thinking through all the different details. It's fun. From a cost perspective, it takes X to shoot something up into space as a satellite, and now you've got some breakup. So now it's denoted as debris. Now what you're proposing to send up another spacecraft to get the garbage. And so from a cost analysis, you're in a losing proposition. From an entropy standpoint, if you're only collecting one bit of trash per launch, that's a very expensive proposition.
That is true, and that's why in the initial stages we're trying to go for like larger satellites that could pose more of a risk to other manned missions of some sort. That's one thing that we're trying to tackle. Second of all, and that's what we're saying about reusability. If we can capture reusability of some sort, that would be like the holy grail of our invention, right? Get a reusable spacecraft that could take out space debris. That could really improve our current design and take it to like the next level, right? So once reusability is established, that could really help our design.
So there's no proposal of some kind of space fishnet, like a solar wind sail to collect debris? So rather than getting one piece in one launch, you could get millions of pieces per launch?
Oh, sorry. Go ahead. We couldn't hear you.
Oh, I was just thinking that I'm just surprised that when you're going through this space debris problem, there hasn't been suggestions of using like a solar wind, like there's ideas of making these huge solar wind sails that would also serve to collect space debris. So rather than collecting one, where I'm going is why collect just one bit if you come up with a different mechanism to collect more bits?
So,
like a net.
Sorry, I couldn't really hear your question, but I think it was about a way to capture more space debris at once, correct?
Yeah.
Yeah, okay. So the thing with a lot of like capturing smaller debris, we had discussions amongst our group. It's the major issue is with a lot, since there's so much energy with all these space debris, it's really hard to capture all of them at once when they're going in different directions. And if one of them was saying coming opposite to you, that your solar sail would completely rip. And that's the problem with capturing a lot of space debris at once.
Okay. I thought in terms of the larger spacecraft, I thought that's not the problem, that they're designed to fall out of orbit and burn up. So, because what you're doing is essentially what I thought they were designed to do, so that the space debris comes from alternative sources like there's collisions in space and small meteorites that break up material and spin it on and make it fill the space. So how is it? Aren't these satellites in the design? Aren't they designed to go in to eventually cascade into the atmosphere and burn up?
Can you please repeat that question? I had a little bit.
Right. So when people launch different satellites, they're a finite lifetime.
Right.
And so I thought that they were designed to basically spiral in and eventually burn up, so that they don't need your system to come and slow them down. They will naturally fall out of orbit and burn up. So how does your approach, maybe you have to help me in understanding what systems you're after.
Right. So that is definitely true that over time, over many years, orbit decays and decays until it actually hits the atmosphere. Our main concern is as more satellites go up, the risk of a collision is quite exponential, right? So we have to take the debris out now, because this is like the time that this time we have to act. If we want to ensure that we can go into space later, we have to act now. So we have to start cleaning up stuff before it gets a way too big of a problem to handle.
Okay, thanks.
I've got a couple of questions. Sorry, just let me ask. It's actually a really great topic for me, because I'm actually the space debris mitigation lead at on my satellite program right now. So I'm very familiar with this topic, and I'm glad that you recognize it's already a big issue, especially at your age. The two questions that I have, the first one is, you mentioned to use LiDAR to detect space debris. Now, have you looked at maybe the effective range of LiDAR, because in space, we're talking on the order of kilometers of magnitude between, debris essentially. And so will the LiDAR be able to actually detect objects from so far away?
Right. So we've done a lot of research, and we've learned that NASA has a giant database of the space debris that they've tracked. So it would be very useful if we have a kind of conjunctive effort, as in we learn the NASA, it relays information that as to where the space junk is. The Kodra actually goes there. Then it uses shorter range LiDAR to actually detect the space junk. And then there's like a correlation effect between those two sources of information.
Okay, so you don't think using like an onboard camera and then having an operator would be more effective, as opposed to using you opt to use a LiDAR instead?
But if we use the NASA database, that could be a more effective way, as to because they have like a giant database of very specific location.
Yeah, and the second question is about the reusability. Now, since your frame is made of aluminum and you're coming back down to Earth, like you mentioned, your system's going to demise. It's going to burn up on reentry. How do you plan to reuse your system if literally 99% of your spacecraft will burn up, at 78 kilometers above the ground?
Again, so our reusability design is still in the rudimentary stages, but thus far we've thought of having expendable tanks, right? So we have extra fuel and extra oxidizer tank. Once those are depleted, they're actually tethered to the space debris. So when the electromagnet turns off, the tether pulls the fuel tanks out with it. So when the space debris is let off, the fuel tanks also let off, and then we replace the tanks, and then it boosts just the Kodra, not the space debris, just the Kodra back into orbit.
Sorry, so you have a system to replenish the tanks in space? Is that what
we're planning to carry onboard tanks, like in the illustration on a couple of slides back. there is an illustration of like multiple tanks of fuel and
Oh, I
oxygen.
see. Why don't you just have one big tank then? Why do you have multiple tanks?
Can you repeat that question, please?
Why do you have multiple tanks? Why can't you just have one big tank of fuel for the lifetime of the mission?
That is definitely possible, but the main the concern is, let's say we had if we use the multiple tanks approach, it would, number one, limit the size of the spacecraft, but two, once we expend those tanks, we can just remove the dead weight. So we'd have to accelerate less.
Oh, thank you. Yeah, great presentation. I love everything about space debris, so I'm glad it happened this year at SRHacks. Thank you.
Thank you.
Okay, thank you very much for that interesting presentation. Let's give a final round of applause for all of our competitors who have presented today. I think you guys all did an amazing job. Great to see all the innovations. So now we have a short break. We're going to be setting up booths for our finalists. This will be the setup for our booth mingle session, where audience members will have the opportunity to come up to the front and look up close at the products that our finalists have made and ask them any questions they have. So we'll get that set up during this short break. To all the judges in the room, we will send you a separate Zoom link for you to join. We will discuss the ranking of the finalists, and after, when we return at approximately 3:45, we're going to announce the winners and the rankings of this year's SRHacks. Thank you. Okay, everyone. Let's settle down a bit. We hope you enjoyed the booth mingle that we had. We're now going to go ahead and announce the rankings of each of our finalists for SRHacks. So if we can just take a seat before we go ahead and do that. We're going to, well, Jenny here, one of the MCs, is going to present each finalist and their ranking. Mimi here is going to give them their award, and they're going to get their picture taken behind this banner by Tara, who is a staff member of SRHacks. Yeah. So now I have Jenny to present the awards.
Reminder to all contestants. So please, when we call your name, you can walk down at the left side of the aisle, come get your awards from Mimi, and then to the banner to take your photos. And after all of our awards, we will have our judges make some concluding remarks. Without further ado, in 5th place, we have Jerome Stevens.
Are there to be comments made now? Hello?
And in 4th place, we have Bryan Ho. In 3rd place, we have Evelyn To and Jessica Q. And in 2nd place, we have Kian Soni, Ansh Shah, Aryam Marwaha, and Xavier Sidhu. And finally, our winner of the 2022 Science Rendezvous Hackathon is Ryan Rad.
Now that we presented our finalists, I think it would be wonderful if we get our judges to provide some feedback on their decision of the ranking. So I'm going to turn it to our judges now. So first up, we have Jerome Stevens.
Yeah, right. So Jerome, this is Dwayne Miller here. I'm chair of Science Rendezvous, and I just want to congratulate you on a really great idea. Can people hear me?
Yep.
Yeah. So this whole food sustainability is the problem of your generation, and you've identified it. There's a whole field called vertical farming, where LEDs have now achieved a factor of 90% electrical to solar output and reduced the cost to just half open field farming. And so your idea plus a little tweak is right in resonance with what is called vertical farming. The hope for your future is to reduce the agriculture footprint by a factor of 10. And if we can do that, then we have a sustainable future. Global warming, all these things are due to the fact that there are 7 billion people on the planet and a huge amount of agricultural space. So you're to be congratulated on identifying a really important problem. And we loved your idea and we loved your creativity with the design. And I can only add one thing. If you want to come to the University of Toronto, I'd be happy to give you a tour of the lab and we can talk about vertical farming. Well done.
Yeah, let's give a round of applause. Next up, we have the Smartben Alexa.
Hey, Brian, it's Brian here. So first of all, again, congratulations on, congratulations on all the research you've done for your Smartpin invention. It's definitely a big problem to address. I have a little experience kind of the environmental side of things and understand that littering, especially in Canada, we don't have the best sorting systems, and it's a problem that's been increasing for the past decade. To kind of put in perspective, I had a chance to work for Google X a couple years ago, and there was a full program there dedicated to sorting out garbage. And we had the exact same color bins as you had. We had a green, blue, and we had a black bin. And we had a ton of engineers working on a way we can sort garbage out because it was a pressing issue in the States. And so to be able to come up with an idea very similar to what we had at Google, you should be very, very proud of yourself. You mentioned you had 2 years of Python experience and you worked with Alexa developer console. At your age, I'm very impressed because this is things that I've seen people even my age in my career have struggled with. So you're very, very well ahead of very well into your career. Yeah, very proud of yourself. Very impressed with what you've come up with, and congratulations once again.
Round of applause. So is the judge who's going to give feedback on the EEG present right now?
Yeah, so Jessica and Adeline, great presentation. You are great presenters as well, and you well explained the concept. We really wanted to hear more about the cost of electricity, how we can save more electricity, and really we would love to hear more about how we are going to assure the security of the people using the elevator. So I think that's going to be your future focus on these aspects. And I'm going to tell you that future is now, never settle, and continue hard. Bravo and congratulations.
Round of applause. Now turning to the Kodra spacecraft.
Yeah, hi, Kodra team. Brian here again. So first of all, I'm very glad that space debris made it to the SRHacks here because that's something that I work with. I work with NASA, I work with the EASA, I work with multiple government industries on space debris, and it's a very pressing issue. And maybe you've heard of the term Kessler syndrome during your research. And we don't know if that's going to happen in the next decade or maybe 5 decades, 50 years from now, but it's a very pressing issue. What you've done really embodies the spirit of engineering. You did trade-off studies, what propulsion tank you should use. You looked into the frame, aluminum versus steel. All that really embodies a true engineering spirit. And I was very, very impressed to see folks your age really embodying kind of what we do in engineering and what I do on a day-to-day basis. So what you guys done with your Kodra, the CAD modeling, the trade-off studies, and just overall an engineering kind of approach to a solution or to solution for a very pressing problem. You should be very, very proud of yourselves, and definitely congratulations on your second place today.
Round of applause. Now we have our in-person judge, Chuck, who's going to give feedback on our winner of SRHacks, Ryan Rag.
So Ryan, you've done an incredible job. You find a very unique way to solve an important community problem, which is really thinking of how to engage our community members. But you do that solving two main problems. You provide a source of income for these community members while also getting them engaged and dealing with issues related to waste in the community. So very brilliant idea, and I hope you further pursue this idea. Congratulations once more.
Wonderful, round of applause. Yep, just another congratulations to everyone. Just a round of applause for everyone who competed today. We were very impressed, and the judges were all very impressed with everyone's innovations and projects. The fact that all of you made it here as a finalist is already impressive, extremely impressive.
We would like to acknowledge the people that made this event a big success. First off, our mentors. We also extend our gratitude to our judges, both those present in today's event and also the judges for our round 1. Of course, we can't forget all the organizers from the Science Rendezvous team. Thank you all so much. And finally, a huge thank you to the University of Toronto, Science Rendezvous, and NSERC, the Natural Sciences and Engineering Research Council of Canada. We appreciate all of you coming, and please have an amazing day.